All right, people, welcome back to this lovely Tuesday, September 29th. Yesterday, we talked about how to write an inverse and how to find an inverse. So remember, you switch your x and y and solve for y. I said that 17,000 times yesterday, so hopefully that stuck in. Today, if I give you two equations, instead of taking one and solving it for the other one, and the other one solving it for the first one, I'm going to show you a different way to prove that two functions are inverses. So you got a cool little picture right here. You got a staple remover and a stapler. You can get the joke. It's awesome. I love it. But to prove two functions are inverses of each other, we need to use compositions, which we talked about last week. You have to do a composition in both directions, and each composition must equal x in order to call the function inverses. So you have to do it in both directions. It's very important. Both directions. And it must equal x in both directions to call them inverses. So that's what we're going to be doing today. So let's look at this. So are they inverses? So I got piece by piece. I don't like this yellow again. I'm going to change them. I need to go through and figure out if there's a setting, but that's a whole different lesson. All right, so f of g of x. All right, so let's go ahead and do this. So my f of x, if I write that out, remember, I'm going to start writing my f, and then wherever I get to an x, I'm going to plug in my g of x. So 7, there's an x already, so I'm going to plug that in. And then I got a minus 2. So I have my function. I got g of x inside of f of x. So let's distribute it and see what happens. So 7 times 1/7 is just x. 7 times 2, 7. 7 times 2 is 14. 14 divided by 7 is 2. And then 2 minus 2 is 0. So I just get x. So that's great. Now let's do it the other way. I'm going to do g of f of x. So I'm going to start writing g. So 1/7. Oh, there's an x already. So 7x minus 2 plus 2/7. So let's distribute this. So 7 times 1/7 is just 1, so I just get an x. 1/7 times negative 2 is negative 2/7. So those cancel, so I just get x. Boom. So if we are looking at this, I got x both times. So f of x and g of x are inverses. Why? Because f of g of x and g of f of x are both equal to x. So this is your definition. That's what we are trying to prove every time. Once you got your conclusion, once you know it, you don't have to write it every time for me, but make sure you know that that is the reason why. F of x and g of x are both inverses of each other because f of g of x, the composition, was equal to x, and g of f of x, that composition was equal to x. So since they're both equal to x, they are inverses of each other. All right, let's look at B. All right, so let's do the first one. So f of g of x. Oh, I screwed up my spot. So I got f, so 4, there's an x. So x plus 3 over 4. Made this hard on myself, skipping. So when I simplify 4, those cancel out. So I got x plus 3. I shouldn't have done that. Different colors. Trace that over. That's purple. Use your imagination. So 4 times that division, 4 times 1/4. Those cancel, so they're 1. So I got x plus 3 minus 3. Those cancel now, so I just get x. So that's beautiful. All right, let's look at the other side. G of f of x. So, I already got an x. Jeez. So 4x minus 3 plus 3 over 4. So if you look at that colors, I already replaced that x with that other x. So simplifying, negative 3 plus 3 is 0. So I just have 4x over 4. Those cancel, so you get x. So f of x and g of x are inverses. Why? Because f of g of x was x and g of f of x was x. So since they were both equal to x, we have inverses. All right, 2 more. So we are proving these today, so you're working on your compositions, getting used to this. So I'm gonna do purple and orange again because that blue made it a little hard. So let's start with f of g of x. So cubed root 2, oh, there's my x. So x cubed plus 5 over 2 minus 5. All right, this one's pretty nasty. So let's look at it and see what we can do. So inside, that minus 5 is on the inside. So let's take a look at what we got. So 2, 2, those cancel. So I still got the cubed root. I have an x cubed plus 5 minus 5. Those cancel. So cubed root of x cubed. The cubed root of x cubed is just x. So we're good there. That was pretty good. It looked a lot harder than it really was. Let's do it the other way around. So g of f of x this time. So there's already my x. Stop moving. So cubed root of 2x minus 5. All of that is getting raised to the third power because it's x cubed plus 5 over 2. So let's simplify what we know. So the cubes cancel, so I got a 2x plus minus 5 up top, then plus 5 over 2. Negative 5 plus 5 is 0. 2x divided by 2, the 2's cancel, so I just have an x. Beautiful. So are they inverses? Yes. So f of x and g of x are inverses. Why? Because f of g of x and g of f of x are both equal to x. All right, last one. If you don't get x, you get anything besides x, they are not inverses. I'm not going to show you those right now, but when you're doing your work, if you get anything that is not x, it is not an inverse. I'm showing you the ones that do work so that way you can actually see it. All right, so f of g of x equals parentheses. Well, there's my x. Over 4 cubed. I hope the colors kind of help you see this when we're getting to compositions. So the purple one has always been my g of x. Well, I guess I'm not going to say that, but in this example it is. One's always been one color, one's been the other color. So up top, positive 2 minus 2, those cancel. So 4 cubed root of x over 4. 4's on the outside cancel. So I have the cubed root of x cubed. Cubed root of x cubed is just x. So that's beautiful. Let's switch them. So g of f of x. Stop being crazy. So 4 times the cubed root of all of this. So x minus 2 over 4 cubed. I didn't plan that out. That looks terrible. But you get the point. All right, let's start simplifying. So the cube and the cube cancel. So I have 4 times x minus 2 over 4 plus 2. The 4's cancel. So x minus 2 plus 2. Those cancel. Just got x. So once again, f of x and g of x are inverses. And I'll end with a bang. Because f of g of x and g of, be consistent. Oh well, something happened. I hit a button. I'm not gonna go through and edit it. That's not my style. Oh man, I'm struggling to finish this. It would have been under 10 minutes, but no, it's not because I'm dragging this on. So g of f of x are both equal to x. Now, you could have written it the same thing, f of g of x, g of f of x. Remember, those are the same notations, so the whole point today, we are doing the two compositions, and for them to be inverses, both compositions have to be equal to x. So keep your operations in order. If you have questions, please let me know. Great job. Today, there is a quick check that goes over yesterday's stuff and today's stuff. So make sure you're knocking that out. It's short, it's a quick 7 or 8 questions for you, all multiple guess. Hope you have a wonderful day, and I will talk to you later.